Soil usually consists of particles of different sizes in varying quantities. The particle sizes and their distribution in a soil influence the engineering properties of the soil. The different particle sizes and their distribution can be determined by mechanical analysis. The result of grain size analysis are widely used in soil classification, filter design for earth dams, soil stabilization, soil compaction, etc. Particle size distribution of finer fraction like silt and clay is determined by sedimentation method using Stokes law. In this program, grain size distribution of coarser particles like sand and gravel shall be obtained by sieving the soil sample through a set of sieves using IS code 2720 part 4. The apparatus required for conduct of this practical includes set of IS sieves of 100 mm, 63 mm, 20 mm, 10 mm, 4.75 mm and 4.75 mm, 2 mm, 1.18 mm, 600 micron, 425 micron, 300 micron, 150 micron and 75 micron size with lid at the top and pan at the base. Riffler, thermostatically controlled oven, trays and brush. First of all, dry the soil sample received from the field in an oven. Depending on maximum size of particles present in substantial quantity in the soil, the weight of soil sample to be taken for analysis may be determined as per table. If the maximum size of material present in substantial quantities is 75 mm, then the weight to be taken for test is 60 kg, and if it is 40 mm, then weight to be taken for test is 25 kg. Similarly, we can take the weight of the sample to be taken for test as per this table. Take a representative sample of soil by using a riffler. On the basis of percentage of silt and clay particles present in the soil sample, the analysis may be done either by dry sieving or wet sieving method. Dry sieving method. First of all, sieve the sample through 4.75 mm IS sieve. The purpose is to separate the sample into gravel fraction and sand fraction. Weigh the gravel fraction retained on 4.75 mm IS sieve for coarse analysis. In this case, the material retained on 4.75 mm sieve is 14 gram. Sieve the material retained on 4.75 mm sieve through a set of sieves, that is 100 mm, 63 mm, 20 mm, 10 mm and 4.75 mm. Agitate the sieves for a minimum period of 10 minutes so that the sample rolls in irregular motion over the sieves. After completion of sieving, take the weight of material retained on each sieve. The material retained on 100 mm sieve is 0. The material retained on 63 mm is 0. The material retained on 20 mm is 0. The material retained on 10 mm sieve is 0. And the material retained on 4.75 mm is 14 grams. For finer analysis, sieve the material passing through 4.75 mm IS sieve through a set of sieves, that is 4.75 mm, 2 mm, 1.18 mm, 600 micron, 425 micron, 300 micron, 150 micron and 75 micron size. Agitate this set of sieves for a minimum period of 10 minutes in a similar manner. After completion of sieving, take the weight of material retained on each sieve. The material retained on 4.75 mm is 0. The material retained on 2 mm is 0. The material retained on 1.18 mm is 128 gram. The material retained on 600 micron is 136 gram. The material retained on 425 micron is 208 gram. The material retained on 300 micron is 222 gram. The material retained on 150 micron is 216 gram. Now collect the soil fraction retained on 75 micron ISC in a container. To dislodge the silt and clay particles, soak this fraction in a solution of 1 gram of sodium hydroxide and 1 gram of sodium carbonate per liter of water. The amount of dispersing agent may be varied depending on the type of soil. A dispersing agent may not be required in case of all the soils. In such case, the wet analysis may be carried out without addition of dispersing agent. Wash this soaked sample thoroughly on 75 micron size using water until clean water passes through the sieve. Dry the sample retained on 75 micron ISC in an oven. Record the weight. The material retained on 75 micron is 28 gram. For better accuracy, repeat the same procedure 2 more times with different samples from the same site. After recording the material retained on each sieve, we shall calculate the percentage retained. Percentage retained on 100 mm is 0, 63 mm is 0, 20 mm is 0, 10 mm is 0. In case of 4.75 mm, it is 1.4%. 2 mm is 0, 1.18 mm it is 12.8%, 600 micron it is 13.6%, 425 micron it is 20.8%, 300 micron it is 22.2%, 150 micron it is 21.6%, and in case of 75 micron it is 2.8%. Now we shall calculate the cumulative percentage retained. Cumulative percentage retained for any sieve is equal to cumulative percentage retained on the previous sieve plus percentage retained on the same sieve. Now record the cumulative percentage retained for different sieve in the performa accordingly. 63 mm sieve with 100 mm sieve, on 20 mm sieve it is 63 plus 20 mm sieve, similarly for different sieve. Now we shall calculate the percentage finer. Percentage finer N is the difference of 100 minus cumulative percentage retained on different sieve. In case of 100 mm it is 100, 63 again 100. Similarly for different sieves we will record the values. Now draw a graph between particle size on the x-axis and percentage finer on the y-axis on a semi-log graph paper. Determine the values of D10, D30 and D60 from the plotted graph, where D10 is 10% finer than size, D30 is 30% finer than size, and D60 is 60% finer than size. For the present case, the value corresponding to D10 is 0.170 mm, the value corresponding to D30 is 0.310 mm, and the value corresponding to D60 is 0.480 mm. Now we shall determine the uniformity coefficient Cu which is equal to D60 divided by D10, and coefficient of curvature CC, which is equal to D30 square divided by D10 into D60. By putting the values Cu equal to 0.480 divided by 0.170, which is equal to 2.82, and Cc equal to 0.310 whole square divided by 0.480 multiplied by 0.170, which is equal to 1.18. Now for classification of soil, we refer to table given in IS code 1498. Determine percentage of fines. If it is less than 5%, then classification of soil will be GW, GP, SW and SP, and if percentage of fine is more than 12%, then it will be GM, GC, SM and SC, and if it is between 5 to 12%, then borderline cases it will require dual symbols. The soil will be GW if Cu is greater than 4 and Cc between 1 and 3. It will be GP if it is not meeting this requirement. The classification of soil will be GM if IP is less than 4, and it will be GC if IP is greater than 7. In case of IP between 4 and 7, then it will be borderline cases and will require dual symbols. Similarly, the classification of soil will be SW if Cu is greater than 6 and Cc between 1 and 3. It will be SP if it is not meeting this requirement, and the classification of soil will be SM if IP is less than 4, and it will be SC if IP is greater than 7. If IP is between 4 and 7, then it will be borderline cases and will require dual symbols. In our case, the percentage fine is less than 5%, so classification will fall in this group. In our case, Cu is 2.82 and Cc is 1.18, which is not meeting this requirement, so the classification of soil will be SP, which is poorly graded sand. In case silt and clay particles are present in considerable amount in the soil sample, the analysis of the soil may be done by wet sieving method. Dry the soil sample received from the field in an oven. Take a representative sample of soil by using a riffler. A dispersing agent may not be required in case of all the soils. In such case, the wet analysis may be carried out without addition of dispersing agent. Wash this sample thoroughly on 75 micron size using water until clean water passes through the sieve. Dry the sample retained on 75 micron IS sieve in an oven. Sieve the sample through 4.75 mm IS sieve. The purpose is to separate the sample into gravel fraction and sand fraction. Sieve the dried sample through different sieves for analysis and interpretation of results. Grain size analysis is usually used to classify the soil containing sand and gravel fraction. In case silt and clay particles are present in considerable amount, then determine its liquid and plastic limit for better accuracy.